My name is Jose Antonio. I come from Aitiip Technology Center. This is me. So Aitiip is a technology center devoted to development and also to make industrial services. So we are quite modest. We are 120 people working on research and this kind of services providing to the industry. We are a research center quite close to the industry, and one of our main intention is to try to transfer the technology we develop to be adopted in the industry, in the companies, mainly in the SMEs. So we have a quite large net of collaborators that are watching every day our Kraken prototype and the laser tracker from Hexagon. That is the main brain of this machine. Our research lines can be divided in 4 main lines. So advanced materials, so we are experts in the thermoplastic and metals. Advanced manufacturing, that is the line that I'm the responsible for. Advanced recycling technologies and also sustainable solution and processes. So in the line of advanced processes, we started in 2012 with a research project funded by the EU. And in this case, our main partner was Hexagon. We wanted to develop this robot, this large robot with a controller enabled by the metrology provided by Hexagon with a laser tracker. We started with a laser tracker 901. And then we collaborate also with Hexagon to develop a second version of the system, improving the capabilities. That was Kraken. And we have kept working since then to our last research project, that is Bioptake. And in the meanwhile, we have been making demonstrations and different proofs of concepts for several industries, several demo cases in order to show the people how the system is performing and all the benefits of using the automation provided by Hexagon in this case. So this was the project that the second project that we designed with Hexagon. So our intention is to try to develop a machine very accurate, investing the least amount of money as possible. So we developed this kind of gantry crane that is quite cheap, and the robot, industrial robot, this one is a Comau that was tracked in real time by the laser tracker. We developed, as Adrian, a controller in order to know the exact position of the TCP. You can see a TMAC on the tool handle of the robot. So we are tracking the position and we are correcting in real time the 6 axes of this robot in order to be quite accurate. We started with milling applications, and then in 2016 we started with this 3D printing. So what we are developing is a kind of a hybrid manufacturing to profit from the benefits of additive manufacturing, but also to have the precision on the manufacturing of the part that is subtractive one. So you can see in every moment the system is tracked by the laser tracker with the automation box. We have this TMAC in order to try to converge in the real position. So in this quite large cell that is 24-meter long, 6-meter wide, and 5-meter high, we can achieve 0.3 millimeters of 3D accuracy because we control X, Y, Z, and also the turns in the 3 axes. So this system was designed in order to profit from milling, from arc spray of metals, and also that additive manufacturing, both in polymers and in metal. So this is our render we designed with Hexagon in order to be clear what we wanted to achieve. And also the final quality check of the part can be made because we integrate also the laser scanner from Leica in order to have the full quality check and dimensional check of the parts we are producing. So this was an European project funded by the European Commission, where Hexagon collaborated and some other partners in order to develop this technology. And after that, you will see some application of the system. You can see here the real setup. In this case, it's milling in shape, kind of mock-up for a museum in Qatar. And it's milling wood in order to make a very large mock-up of terrain reconstruction and some ruins reconstruction. So this way, we wanted to know the robustness in the system because it's not stopping during 10 days. And you can see that that's the performance. Some moments you will see that it's going night and day, and it changed the luminosity. So this was one of the performance that we made. This is a 200 square meters mock-up. And if you go to Qatar Museum, you can see it inside. We can also print, in this case, polymers. We can print very fast, 120 kilos per hour, and we combine with the milling. In every moment, you will see the TMAC in the robot. You cannot see it in the image, the laser tracker, but it's working too. So we can print this kind of shapes that in this case was also a demonstrator in Kraken project for Pininfarina, that is a car and yachts manufacturer. So in this case, you can see the performance of 5-axis milling system and also the printer in order to achieve this kind of mock-up that is half the size of the real luxury car. And in this case, we wanted to, you can see all the chips, and the system is working perfectly. We are tracking in real time. We are obtaining very good data, and we can correct in real time the performance of the robot. So this was a big challenge for us and for Hexagon, but in this kind of dusty environment, it works perfectly. So then you can see all the parts of the car that are printed and milled in shape, and then you can assemble it in position. And after the polishing and painting, you can see the final result of this work. And also another trend, another challenge was to make real-time control of a metal 3D printer. This is one of the biggest parts in steel that were done with very good precision in this case. And you can see this kind of time lapse. This part is close to 2 meters long, 600 centimeters high, and it's weighing 1,000 kilos. And it was printing in 8 days non-stop. So everything is tracked in this case with Hexagon products, and everything is well performing. And it's my main message. So we have been collaborating with Hexagon and Leica for many years, and we wish to keep on working with them because their products are very good for automation. And we wanted to make this kind of demonstrations in order to show the industry the possibilities to develop machines very accurate without having a very robust structure or even a very robust kinematic chain. Okay, so thank you very much. You have my contact there. So if you have further questions, I will be very glad to answer now or even afterwards by email.